So what we are going to do to start with here is I'm going to ask our new panelists here, each one of them, to introduce themselves briefly, and then start with talking about one technology that you are exploring or excited about to use in your personal life or in the plant in the near future. Maybe how about, could we start with you, Stuart?
Oh, thank you very much. First, I'm Stuart Madnick from the Information Technology Group at the MIT Sloan School of Management. I'd like to start off with a question.
Here, pass it down.
Is that better now?
Yeah,
Thank you, I appreciate that. I won't repeat, I'm Stuart Madnick from MIT. But I have a quick question for the group here. I don't know how many of you go back in history enough, but how many of you here remember a company called Digital Equipment Corporation? Anybody? You may remember it was the second largest company after IBM at one time. But the thing I want to point out, there's a famous expression, what is it, that it's very difficult to make predictions, especially about the future. So Ken Olsen was the founder and president of Digital Equipment Corporation. And he's very famous for a quote he said. This is probably in the maybe late 1970s when the Apple II was coming out and the early IBM PC was coming out. And he said that I can see no practical use for a computer in the home. There was a pause, and maybe it could be used for keeping kitchen recipes. Question, how many of you have at least one computer in your home? How many of you keep kitchen recipes on it? The reason I'm saying that, of course, is being able to predict how things are going to play out is extremely difficult. And you have many other examples in your life. So with that kind of as a caution, let me try to address Andy's question. I think the thing that I find fascinating, and very consistent, but it's a different twist on the introduction of the IBM Watson, is this whole Internet of Things thing, if you will. The idea that there will be literally billions upon billions of devices around. My own particular research area, by the way, is cybersecurity. I'll be glad to talk more about that later on in the questions. But the example I use is they're now moving into the kitchen. I think LG has a internet-connected refrigerator. An example I use is my brother is one of those folks, when he wakes up in the morning, cannot function until he's had his cup of coffee. Say, imagine a day when you get an email message that says, we have hijacked your computerized coffee pot. And unless you deposit $500 as account, you will not get your morning coffee. So those are the kind of things in terms of new technologies and the challenges that new technologies have. Thank you very much.
So my name's Mike Dudzik. I'm General Manager of Process Automation at ArcelorMittal Dofasco in Hamilton, Ontario, Canada. We're the largest steel company in the world there. In terms of technology, the area that we're very excited about and really exploring these days is the big data and advanced predictive analytics. So an area that we're focusing in on is less on the size of the data, but more on maximizing the value of all the data that we have. And here's an example that maybe one of you end users might think about when you're looking at your plant, is that you have a lot of process data. Your operations is looking at trying to understand different abnormal operations. Your operators in the control rooms have different cameras and different viewpoints on looking at the process and that. But most of your models, most of the analytics that you do today are based on process data, structured data. What we're seeing in the big data space here is that marrying of structured and unstructured data. So areas that we're exploring, areas that you might want to investigate might be, could you marry some of your video data, those cameras that are in your pulpits or your control rooms, and marry that with process data to give you signatures of different abnormal operations, giving you insights into what might be a problem for you there versus just the process data there.
Good morning. I'm Paul Comudi. I look after technology and strategy for Ingersoll Rand. We're a diversified industrial company making everything from commercial air conditioners all the way through to electric vehicles with Club Car. We have a lot of technology opportunities in the company, and the one that I'm sort of most excited about right now is around this topic of data analytics. but you know, the spin that I would put on it is we're working on a lot of different sets of technology, from cognitive computing to machine learning to some basic data analytics, in order to empower our employees to do a better job for our customers, right? So, I know we focused on manufacturing, but if you think about it, one of our businesses, we make trailer refrigeration units, and it's sort of really important. The quality of those products are important. And how do we take that structured and unstructured data in order to get advanced warning signs? Because of a lot of times our customers or our field service people take problems away from our customers that we should be solving back in our manufacturing operations. And so gathering all that data, really using learning and cognitive computing in order to be able to get ahead of that, to give our customers a better experience with regard to quality is just one example. And so, there's many other technology examples, but I do think that there is something around this analytics space that's really important.
I'm Carol Ide, I'm with ExxonMobil, and what I wanted to talk about was actually a little bit different from what these gentlemen have, because we're doing all of those things, and I'm excited about all those things. But one area that hasn't really come up yet is, and I think it's really a challenge not only for us, but for the whole industries, is in learning, experiential learning, and how do we harness the data that we've captured and the knowledge we have in our experts to bring on the next generation. One of the things we're considering exploring is better use of our operator training simulators to develop the expertise in our engineers. And this cognitive learning process that we just heard about is really interesting from the aspect of how could we harness that to grow capability. So that's the thing I'm most excited about at this point, in addition to the data analytics that we've been talking about, and operator capability that you guys just mentioned.
Excellent. Before we go here, let me ask you, please raise your hands in the audience if you have questions. Could I ask ARC folks to please come around with the mics in the room? Could we have some mics? And there is a question here. Okay, there. So please get your questions ready, and we will bring mic to you. In the meantime, I'd like to ask a question from the panelists here. Obviously, as we are talking about all these new technologies, I think we have to prepare ourselves and our people to really be ready to deploy and use these technologies. And I'd like to actually maybe start with asking Rob at the end here, maybe what do you think companies need to do to get their people ready for using cognitive computing or other technologies in the organizations?
Yeah, good, thanks, Andy. There's two sides of that. One is getting ready to make use of cognitive systems in the jobs that we have to get done, and how we apply that in our everyday workflows and activities. The other side of that, of course, is teaching these cognitive systems around the areas of expertise that we have or that we need for them to have in order for them to facilitate that. So in the first case, there's a tradition, and Paul, I think maybe you touched on this, that we are kind of focused on quantitative data as the way that we think about the utility of computing to solving problems in our space. Sometimes we may use the computing capabilities to also deal with workflow problems, but mostly we're dealing with quantitative data and learning that there is something of utility in the unstructured space as well. And learning how to blend that is actually takes a mind shift. You have to kind of think about the utility of these non-mathematically modeled ways of reasoning as having utility and something that we can exploit. And there's a mind shift that has to do with that. I still deal with people in the financial services area that do a lot of, trying to figure out what investments are most appropriate for their clients, and they are fixed on It has to be mathematically modeled. It has to be based on quantitative data. They actually refer to themselves as quants. And realize that there's something in the subjective space that we're all conditioned to that actually influences markets, influences investment quality just as much as the quantitative information does, that is just as important. So that's a conditioning that I think we have to kind of bring our workforces through. On the other side, of course, is teaching these cognitive systems, the information, and that requires actually spending a lot of time, not just on the practice of education, of teaching, but actually looking at your data and curating it. We have a lot of bad data out there, a lot of material that's been written that is either not of the form that we want it to be in, is not of the information currency that we need it to be, is not complete, huge gaps in our literature around products in particular that need to be filled in before the cognitive systems can really be beneficial.
Carol, would you like to add something to that? What is Exxon doing to prepare your folks?
So for ExxonMobil, one of the things we're really focusing in on is our culture, which gets into what you were saying a bit, is a real emphasis in our manufacturing and our research and engineering organization, and even across the corporation on our behaviors and cultures. The technology, we have very good processes for development of technology enabling, and it's a core value for us and part of our strategy for success. But where the really untapped potential is continuing to grow our capability of our resources and the culture and how we do that. We were having a conversation, in fact, with some of the panel members ahead of this and said, hey, the technology is easy compared to the people. And it goes into just some of the things you were saying about cognitive learning and changing mindsets. So the same thing is on that. And when we talked about innovation yesterday, so how do you anticipate, innovate, and empower your people on a daily basis, no matter what their role is, to prepare them to really embrace the technology that we're trying to drive?
Excellent. Paul, do you have a comment?
Yeah, I mean, Andy, I think it's a great question. So a couple things. One is we come into this not clean and new, right? We've been talking about expert systems, I think, in industry for decades, right? And this was really, I think, positioned pretty incorrectly from the technology community as, a set of rules that we could codify that would replace a person. And that's why kind of when it started off for me, I think the perspective is that, first we have to look at this as an opportunity to empower our employees, right? To get the data and analytics and information, and to encourage everybody to make fact-based decisions is a word that we use a lot in our company. And so, I think, setting the expectation that we're really trying to have the business overall perform at a different level, and the way that we're going to do that is to get our employees and associates really using, the best tools and set of data and facts that we can, is really a starting point. The other thing is we've been kicking around a concept, I don't know if it's been coined an acronym, if I picked it up along the way, of, we have bring your own devices, is really to think about bring your own analytics. There's a lot of really great tools today that you can put on an engineer's desktop, or you can put on, a financial analyst desktop to do analytics, but really they struggle with the data and to really understand how to use that data. And so a lot of the work that we're doing in order to be able to empower our employees is to give them sort of free rein to do analytics that will help them to innovate and solve problems that they're having. Where the center-led teams are really focusing on making the data, both the structured and unstructured data, available. And actually, the stuff that we were just talking about, Rob brought up of analytics as a service or cognitive systems as a service, really lend themselves to empowering our people to be the best that they can be in driving the analytics, because they'll think up things to go do that we couldn't ever envision from the center.
You'd like to add anything?
The only thing I'll add, because all this was excellent input there, is that one of the things that we always have to be cognizant of in the end user community is that there has to be a very strong, in my area, the manufacturing strategy, transformation that we have going forward, a business strategy transformation going forward. And then it's that whole side, and the technology and the people side are the enablers to make these things happen there. So all the things that we do, we have to really understand the business drivers, the business needs, the manufacturing drivers and needs, and then look at technology, look at people, and all the tools and techniques that we need to do to enable meeting those drivers and that, because that's what will get us moving forward.
I would like to maybe broaden the issue a bit. Although MIT is a university, we have always had a long concern about the overall educational process through all ages. And if you're thinking about it, just in the, I guess, Obama's budget announced yesterday, the old 3 R's of reading, writing, arithmetic have become the 3 R's in C, and that is every school child was going to learn how to code. And although I think maybe there's an interesting thought there, I think there is a correct idea maybe buried in there. And that is a more pragmatic, a more analytical way of thinking. That's not just a matter of the employees in our companies, but the customers and the society at large. And I think we're at a cusp now. How many of you have had a member of the family or a neighbor say, could you help me connect my Wi-Fi? Or could you explain to me how to set the timer on my VCR? They still don't have VCRs anymore. I mean, there is a certain type of thinking process that I think is clear that we need to incorporate that, not just amongst our level, but throughout society. And I think that is going to be the next big change. My fears are it's going to stumble a lot before they get it right, but I think that's where things have to go.
Let's move to questions from the floor. We have a question here. Please identify yourself briefly before you ask your question.
Yeah, I'm Abraham from L&T. The question is for Rob. Are there any limitations on the IBM Watson where it can work or where it cannot work? For example, let's say the automated control of a refinery or investment decision in real estate, stock market. Can we set like, I want to make a target of 1 million in 2 years or something? Will it work like that?
So it doesn't really quite work like that. The services are first exposed to a set of corpus, set of data, set of content that serves as this basis of knowledge. And this is done individually for each institution that we set the service up for. And then it is trained in that area. So it's trained to understand the patterns of meaning in that context. And because we do that for each individual institution that we offer the service to, it is entirely up to them to decide what information they want to provide as a knowledge base, what kind of training they want to perform to get it to become expert in that space, and how to implement that within the context of whatever application of technology or workflow they're trying to leverage, exploit. And so the decision as to whether it's appropriate or not appropriate becomes one of the institution. And you'll find this over and over again, a theme that we really would try to emphasize. We're not trying to take decisions away from people. We don't believe we can make decisions for people. What we can do with these cognitive systems is bring the information to them that they need to be able to make a better decision. And so we don't aspire to take over those roles. We don't try to position the technology for that, and we certainly don't develop the technology with the idea that it will. We really try to build the technology with the idea that it's going to be incorporated into a process where human beings at the end of the day are making the final decisions.
Okay. Could we go to question right here?
Yes, is this on? Everyone hear me?
You just start speaking, it will come on.
Okay. I was particularly interested by Carol's input, and this is really both for Carol and Rob. When you look at integrating into an organization or organizational learning for the next generation and training people, there are things that are in manuals, right? Like, okay, here's how a product works, here's how a particularly factory line works. That's very easy to capture. But what about the tribal knowledge? What about the emotional piece that is involved in very important things like the acquisition of a company or the integration of a company into a larger one? And you know, it's very hard to digitize, if you will, the political interactions that you might have amongst organizations and teach that to the next generation of employees. And I'm just curious about how that all gets in. And by the way, I want to link it back to Jeopardy. I'm not a huge Jeopardy fan, but I noticed you had 100 million pages of information. So some human being, right, said, okay, here's the appropriate 100 million pages of information. So it was only as smart as somebody who, you know, took that 100 million, and I bet you there wasn't a lot of emotional intelligence in that, and so that goes back to Carol's point. That's my question. So.
Well, let me start. I mean, so one of the things we've been exploring is yes, you know, there's the procedures and the processes, all well documented, but it's the how do I make choices and decisions. That experiential knowledge is what do we call it, and the stuff that I've learned over my 25, 30 years, and how do I embark that instead of just, you know, and I would say engineers are not good teachers, right? And so they basically say, follow me and watch me and do what I do. So how do you transform that experiential knowledge? We talked about, from a reliability standpoint, everybody wants their equipment to be online. Well, when we learn is when it's broken. So the longer it's online, you have less opportunity to grow that knowledge of the decision making. So it's pretty fascinating stuff, but there are experts out there on how to teach that. If you think about the military, for example, situational awareness, right? Really important. How does a general transition the knowledge he's learned to the follow-up? So there's some deliberate work processes that you can do, and we're doing some of that, but that's kind of tactical. The more is how do you grow it from the day somebody walks in the door? So that's what we're trying to focus on, and we have a few activities in that direction.
Anybody else like to comment?
Well, I guess a related issue that maybe it's hitting into is in most organizations there's what I'll call the documented knowledge, the documented procedures. And then there's what people actually do. Right. And one of the concerns, of course, is that if you only fed into, say, Watson, what it is you think the organization is doing, and you don't have access to what the organization actually is doing, then you're missing something. This is one of the big challenges, whether it be with a Watson or just with anybody joining your organization. A lot of times what makes the organization really run are things that often are not documented.
Yeah. Yep. Let's go to question here. Please identify yourself briefly.
Bill, I'll get back to you afterwards, and we can discuss the rest of the question later.
Bill Leiden, International Society of Automation and Automation.com. Maybe it's a simple-minded question. You know, we live and die on sensor data out of the, you know, in the manufacturing arena. And the term structured and unstructured data, right? I'm thinking Rob High maybe to start. Can you give a simple definition about structured and unstructured data? And then considering that we deal with sensors and these end devices, where is the best place to add context to that data in our system architectures?
So we've fallen into the habit of referring to the world in terms of structured versus unstructured, but in fact that's kind of unsatisfying. For me, it comes down to quantitative data and qualitative data. Quantitative being something that we can put, well, numeric value on, but more importantly, we can define the semantics based on the actual syntax that we associate with that data. So numeric data is simple because its semantics are inherent in its syntax. Structured data is generally in that same category primarily because the syntax is buried in the structure. But qualitative data is the world of the human condition. And that's probably too limiting too, because while I talk about text and audio and vision, in reality, as you point out, anything that can be sensed, whose sensory value is not necessarily intrinsically semanticful, that is, you can't derive the semantics directly from its own value or the way that it was presented, but rather requires that you interpret and evaluate, and whose human value is our ability to judge that interpretation as being meaningful or not meaningful. Those are the areas of the unstructured space that I find interesting. It is, as has already been pointed out a couple of times now, I think, important that we evaluate both And the flaw I think that we have in most applications of information technology today is to limit its use only to that structured space, the quantitative space. We're used to that. We like to justify ourselves on the basis that we want to make decisions based on facts. I think that point was made earlier as well. In reality, that's not what we do. It's human beings, right? We actually blend a combination of facts, intuition, inspiration, a whole lot of things that are not as well founded in the nouns and verbs or the entities and relationships that we might also otherwise associate with facts. And I think when we realize that, when we realize that in ourselves, realize that in our decision processes, when we realize that in our decisions about how we judge things and interpret things, now we can begin to see the utility of the cognitive space focusing on the unstructured information as well.
Any other question over there?
Yes, I have a question. It's concerning.
Could you please identify yourself and stand up?
Oh, sorry. My
Yeah,
name is
thank
Wilco
you.
van der Wol. I'm managing an organization called PLC Open, and I got a question for Rob. Thanks for this excellent presentation, but I'm a little bit confused with the numbers. I see the data growing that rapidly. I see that for Jeopardy, you used a tremendous amount of computing power that doesn't fit in my phone. I know Moore's law, and I hope we still can get it to the next generation where there's a big question mark. How do you think you can cope with that massive amount of growth in data while Moore's law is not that quick? Are you on the right track? Can you deal with the underlying hardware in that sense and the storage?
What's the underlying hardware architecture that facilitates that kind of infrastructure?
Exactly.
Well,
exactly.
yeah. So actually, the answer to that is quite simple. As I said, we had a massive machine that we played for the game of Jeopardy. That was a highly over-provisioned machine. The reality is that we have, through engineering, refinement, efficiencies, taking advantage of Moore's law, of course, all through that. Of course, one of the reasons why we're cloud-based is that we get to put all of that infrastructure dependency behind the wall of the internet. The fact is that our computational space is much more compact than what you experience in the case of Jeopardy. But actually, the more significant part of the answer really goes back to the question you asked, which is that it's not that we're taking all of that 44 zettabytes of data, or 2.5 exabytes of data today, and merging that into a single computational platform. What we're actually doing is going in and finding those slices of that information that for any given institution or any given deployment is focusing on, that's important to focus on, right? And of course, different people have different perspectives, and so in aggregate, you should expect that some significant portion of that 2.5 exabytes is actually going to be consumed at some point, but it's not in a single machine. It's actually distributed over many different instances, and only for what's relevant to that particular domain. You have to curate the data. You have to get rid of the stuff that's junk. So 2.5 exabytes doesn't mean 2.5 exabytes of clean data. It's 2.5 exabytes of raw data. Some portion of that is relevant. You're going to curate that. You're going to distill that. And then you're going to fill it in with what's not actually captured there.
Okay, we have a question here. Please stand up.
I am a founder of a startup, so perhaps you might see this as a plug, but how do you see your organizations evolving to the data analytics challenge, particularly in the form of your people that you already have? So do you see new people that are foreign to your organization at the moment taking the charge and running with the problem? Or do you see a way of equipping your existing people to deal with the data analytics challenge that everybody faces?
Okay, go ahead, Mike.
No, very good question. With our analysis of looking at this space and the big data, these advanced predictive analytics and the complexities in that, we recognize that we need to partner with appropriate experts there, especially to really understand how we can really capture the value from all our unstructured data that we currently have there, marrying with our structured data there. So we have expertise within our organization that we would work with a trusted partner or partners from many different areas that depending on the different use cases that we are looking to explore here. So I think this is the type of realm where we really need to work with partners that have the specific expertise, because these are very advanced areas there. We want to learn from those partners and then hopefully bring that expertise in and then continue to do more and then see what the future holds.
Go ahead. I have a question that maybe relates to the last two questions asked. How many of you in your organizations know, if there is yet, a chief data officer that's been appointed? How many of you? Any of you? I see one or two hands. There's now been formed, just within this last year, an international society of chief data officers. There's about 300 or 400 of them so far. The reason I'm saying that, of course, is I think besides the technical issues of being able to store and gather all this mass amounts of data, is a huge issue with being able to manage this whole process. In my limited dealings with the medical world, which I'm sure Rob has much more experience with, one of the biggest problems they have is first things like getting permission to access the data. I mean, there's a whole host of issues there. The different standards that different hospitals and groups do, whole processes of standardization. There's enormous number of challenges, even more challenging than Moore's Law, that we have to overcome. Good news is there is progress being made, and the idea of organizations creating chief data officers with responsibilities for trying to address these challenges is a step in that direction. But there are enormous challenges we have. Hopefully will be overcome.
Actually, data scientist is probably the hardest job out there right now. So, any other questions out there? Okay, go ahead. Please stand and identify yourself.
Good morning. My name is Martin Hiscox. I'm from AA Investors. Already today, when I pick up my iPhone, I've already abdicated an enormous amount of my intelligence to it. It looks after my diary, it answers nearly all the questions I have, it keeps my memory, well, it actually allows me to enhance my memory. So as you get to the stage where you get cognitive computing that actually will answer many more questions for us, do you think this is going to be deteriorating?
No. I mean, it's a philosophical question. I can't be certain of this, but if you look at history, what has happened in the application of any technologies, whether those are cognitive technologies or physical technologies, is we've been able to use them to amplify our own strength, and then we've used the offloading of that strength to go do other things, pursue other things. You know, you can draw analogies to our children using calculators in school. You know, when I learned my kids were allowed to use a calculator in their tests at school, I was a little bit flippant about it. A little chagrined that you know that they were no longer learning how to do multiplication and addition on their own in their own head, and that they were going to lose something. But the fact is that, you know, my observation is that those kids, mine, but all their peers as well, ended up actually developing other cognitive capabilities. You know, by not spending their time worrying about that, they ended up spending their time thinking about other things. Now, we could argue about how productive that is. You know, the fact that my son's at level 34 of his video game, I'm not sure what that means cognitively, but clearly there's an example there of him being able to do something that I couldn't do, and I suspect a lot of that's because he's offloaded stuff that he wasn't doing before. Anyway, there's lots of debate about that. I'm not sure I'm qualified to really get into that too deeply, but I'm not particularly worried about us losing our intellectual spirit. I have a tremendous amount of faith in the human nature. We are sort of programmed to go pursue intellectual challenges, to go, you know, occupy our mind, to go do fun and interesting things, and I don't think that goes away.
So please raise your hands if you have a question. We could bring Mike to you. In the meantime, I do have a question now. I'm wondering if you could actually talk about if there is some new piece of data or that you wish you had about your plant, or maybe you have a problem, you wish there was a solution to it, or something you really would like, you wish there was a solution, or there was a piece of data that perhaps you wish you could have about your organization or your plant or about your machine. Who would like to start? Go ahead, Mike.
Yeah, so this also gets kind of into that big data space there. So areas that probably interest us are what's kind of outside our organization there. When you look at market intelligence, customer intelligence, all that information there. There's a lot of interesting information that's out there on the internet, the web, social networks and that we need to mine in a more efficient and effective way there. So that's probably the one major one that I would look at.
Go ahead, Karen.
Don Bartusiak mentioned this yesterday in his remarks, but when we look at for our business in manufacturing, what our continued challenge is unplanned capacity loss. And we get lots of data and we analyze it on equipment type failures and the types of failures, our work processes we focus on, and then we also focus on the human side of it. So we have data that we capture on that individually, certainly on the equipment. Where we're challenged is the lack of clarity on the human aspect of it, the people aspect of it, and being able to marry the work process, the equipment data, and have the data on the human factors, and look at that holistically and evaluate it would be a really great opportunity.
Yeah, I would add to kind of just reinforce maybe both of these points. There's really two areas I think in our company that we're pretty focused on in terms of getting better data in order to be able to prove. One is on this OEE side. So we're a discrete manufacturer, and there's still an inordinate amount of unplanned downtime in our machines. And it's sort of beyond just the basic, is the machine running or available or materials available? It's actually tying that into the quality control that we have. So, are we making good parts is an important part of that. And then the second thing I would say, that's a little bit of a bigger one, is on this volatility that we see in our end markets. So, we talk about 2015 actually as one of the craziest years. Nothing that we thought was going to happen actually happened, and luckily a few other things happened in our end markets that helped us out. But you think about how that demand ripples through our operations was really a challenging thing, and so really trying to find a better way of predicting and seeing what's ahead of us with regard to our customers is really an important piece. And then again, being able to ripple that through our supply chain.
Do we have a question out there? Okay, go ahead, sir.
Hi, this is.
Start talking, it will come.
Okay. So Adam Friedstrom with Dow Chemical, and I was curious about, we have a large amount of research type documentation and information that is restricted access to only certain people are allowed to look, but it varies depending on the business unit that the data is. Is it possible to provide that large base of information but still restrict access to based on the user? It sounds like a challenging thing. Is that something that's possible?
So this is an interesting problem. We actually ran into this on a couple of occasions where the information is stratified and access to the information is compartmentalized in the way that you described. And there's a dilemma in that for the cognitive system to perform well, it needs to have an understanding of the context in which any particular question and answer may be posed. But the more that it knows, the better it can do at determining whether what it's answering is correct. So the technique that we've evolved for that situation, which I'm not convinced is entirely perfect, but it's the best that we understand right now, is to in fact expose to the information system, the cognitive system, all the information, irrespective of that information stratification, access stratification. Allow it to take a question and attempt to understand that question in the context of the entirety of that information base, and then selectively respond back to the user based on whether the information, the answers that are produced are coming from sources that were otherwise restricted. And the restriction, because the filtering that we do is actually not to answer the question, but to change the fidelity or the amount of detail that we might provide in that answer, again, commensurate to whether the information is coming from a source that that person has access to or not. So, you know, the problem is that if we only allowed the system to operate on that subset of the information that that individual had access to, then it actually could give that person the wrong, an answer that would lead them in completely the wrong direction, whereas that's a little different than simply preventing them from getting access to the underlying details that are most of greatest concern. But it's an area that really needs a lot more study and a lot more evolution.
Yeah, so I could probably answer kind of our experience more directly. So this is exactly when I was talking about bring your own analytics is something where we're starting is in our engineering and technology and our product design teams, which are spread out all over the world. We have, you know, if you take a look at our commercial HVAC, we have 3 main laboratories, and our engineers start with physics-based models individually. We have a common set of modeling tools that we use, but they'll develop models themselves. Usually they'll order tests in any one of those labs, which are independently done. So we might be testing the same basic idea or validating a model in 2 places simultaneously, but because we've traditionally restricted access to that information, the 2 engineers wouldn't know that they were working on the same thing. We'll ultimately build that product and we'll put it into our manufacturing operation, and our manufacturing operation will test it in line as we're building it, more as a validation testing. But if you think about that data, there's no reason you wouldn't be able to use that to validate the models, but that's sort of in a separate place, and that's 3 different factories, so that's 3 separate factories. And so by the time that you look at that one scenario, we probably have 10 or 11 silos of information that if we could federate that and let engineers think about their own analytics on that data, we would get a lot faster and we would get a lot better in terms of our design cycles. And so we're working on that exact issue right now, and there is a set of technologies in the security area that allow you to manage access down to the individual and actually revoke those credentials if you find out that people are treating the data improperly. But it's a great question, and one that I think you know, is always a balance between access and security. And so we're, you know, that's something where more needs to be done.
Well, this kind of relates to the last 2 questions. One of the views we have regarding big data is it's like a microscope. It allows you to see things that have always been going on, but we never had a way to see before. And I think, so it's kind of a different use, if you will, of kind of the cognitive computing. Some of my colleagues refer to it as collective intelligence. And one of the examples that they demonstrated in one of the projects was being able to predict housing price movements by looking at Google search data. Because by looking at what people are looking at, you can kind of infer what may be on their minds and therefore what their future actions might be. So there's a tremendous amount of value yet to be fully understood and fully harnessed in this massive amount of data that we're collecting, and it can be used for a vast variety of purposes. Those who mentioned about being able to predict the marketing trends and the demand needs and so on. There's a lot of that probably does exist. We just never understood in the past how to be able to harness it.
I think we have a question over there.
Yes, Ed Podozak from IQMS Manufacturing ERP. One of the panelists mentioned describing what we say we do and what we actually do. And maybe it's for Rob, but also for the other panelists. Out of millions of pieces of text and information, it's very likely that people who'd be considered almost subject matter experts could be at polar opposites on the facts. You know, it's this is the cause, that's the symptom. And we've all seen it. We're you know, good people with good intentions totally disagree. How do you reconcile that in a cognitive learning model as data sources?
So, yeah, this is the interesting dynamic of these cognitive systems, is that they actually learn their behavior from experts. And, you know, it's important to understand that there are very few universal truths in the world. So we base it on what we call ground truth, which is the accepted truth of that set of experts that they want that system to learn from. So in some sense, it is putting it back on you to decide who you want to bring to the table as your experts, what ground truth you want the system to learn from. And by learning here, what I mean is interpreting meaning, because the knowledge base is a separate discussion that has to do with curation. But it is, you know, I had a very similar question asked to me by a reporter one time, you know, about the whole autonomous driving experience and these sort of moral dilemmas about, does the car, you know, drive through the crowd, or does the car jump off the cliff and kill the driver? You know, how do you make a decision? Well, the answer to that is that it's going to do what it's taught to do, right? And it's going to learn from experience. It's going to learn from our experience. It's going to learn by observing the way we as humans behave, and from that, adapting that in its understanding and its ability to reason. So it's in your hands. That may be a good thing or may not be a good thing, but the fact is it's still under your control. Get a car stop, yeah. So, yeah, that's it. Yeah. So the autonomous car would never get itself into a situation where it had to make that moral decision.
I think we have a question here.
Hi, I'm Michael Coden from Next9. We're a cloud-based cybersecurity software company. And I have two questions. One is, I don't think we're going to see Watson in every industrial plant. So it's a cloud solution.
It's a cloud solution.
And how, if we're going to use that to improve our, optimize our plants or whatever, how can we protect the data that's transferred to Watson? And the other is, what have you looked at the application of cognitive learning to cybersecurity incident detection? And what's the potential benefit, significant benefit, I think, to doing that?
So on the first question, every instance of Watson is isolated from every other instance. So when we contract with an institution over their needs for cognitive computing, they get their own unique, distinct instance and completely isolated from every instance. And the data that you bring to the table is entirely yours and remains separate from anybody else's data, including the training models, including all the things that you teach it. So that is respected and preserved. Actually, Stuart, I know you've got some background in cybersecurity. Do you want to speak a little bit to the application of cognitive computing to that?
Well, for those who didn't hear the question, I think it's a fascinating question. One of the biggest challenges in the cybersecurity world, I think most rational people now, realize that the odds are someone either is in or will get into your systems. You know, if they broke into NSA, they broke into the Office of Personnel Management, probably they broke it in, maybe they broke it into Watson, for all we know. The biggest challenges I think we have now is to know it has happened. And so one of the things that people are struggling with, and this may be a great use for cognitive computing, is how do you detect that there is activity going on in your computer systems different than what you desire? Now, don't get me wrong, there are lots of products out there that do it. The problem is the false positives. According to at least one report, when Target was being broken into and credit cards were being stolen, 30,000 alerts had taken place that day. The problem is to go through 30,000 alerts to realize that something really was going on overwhelmed the humans. So the question is, can we find a way to detect really fine-grained changes in patterns that are indicative of a cyber attack going on? And I don't know if Watson can do that or not, but that sounds like a fascinating challenge.
I think it's exactly what you said, and it does lend itself very much to the principles that we apply to cognitive systems, which is essentially to sense as many different fine-grained signals as we can and use machine learning to kind of separate the noise from the signal. That is what a cognitive system is doing the extremely large, in extremely large dimensions is the real technical feat. And so I think in that sense, if you could think about the security problem in terms of all the things that represent behavioral signals and interpret behavioral anomalies as patterns, then in principle it should apply, right? And no, we haven't done it.
It just occurred to me maybe some of a broader version of this, and maybe something for you to think about. In your plans, how do you recognize that something is not operating the right way? So it doesn't have to be a cyber attack. But someone kind of watching over your, God, if you will, looking over your plan saying something is going wrong over there. So there's some fascinating capabilities if we can finally learn a way to understand undesirable behavior going on that may be very subtle.
I have a question. I want to extend this, obviously, cognitive computing. We talked a little bit about smart machines. You know, how smart machines obviously get better, you know, every day they operate. I'm wondering if Carol, Paul, Mike, are you exploring bringing some of these smart machines into your organizations, or where are you in regards to that, or when do you think you would be ready to start bringing some of these smart machines into your organizations? Carol, would you like to maybe start?
Well, sure, it would be really interesting. I mean, for us, you know, even on the big data we were talking about earlier, it's always about the value proposition, right, and the justification for it. So, and we go through those processes on a regular basis when we're evaluating applied technology or even our big data. And in fact, on that big data, which is part of really related to smart machines too, is the more data you have in managing it. We looked at that a number of years ago in trying to find the right business use cases, and the technology wasn't there. Now that obviously the technology is here, and that's the real challenge we have, is finding what's the right data. Yes, there's lots of data out there. How do we best utilize it and have that right value proposition for our businesses? So absolutely, we would be interested for the right justifications.
So again, I think there's a couple directions for us. So first of all, in our company, we make a lot of stuff. So every product line that we have, I think, is to one extent or another wrestling with the level of smartness that they're going to have in their product. We haven't shipped a golf or utility.
Paul, I think that microphone's on.
Yeah. I don't. Thank you. So every one of our product lines is wrestling to one extent or another with how smart these things need to be, and you know, I enjoy it. But you know, the golf car and utility car market that we're in, we haven't shipped a car that wasn't instrumented and connectable in a couple of years now. Not much of that is actually helping the customer directly. We do have some applications that do help in that direction, but we gather all the warranty information right now and actually proactively dispatch service on those machines. And so I could talk to a number of different examples of that, but everything that we do, our turbo machinery, our large chillers, and we're working right now on rooftop air conditionings, even air conditioning for your home is connected to dealer diagnostics earlier this year. We also use quite a bit of smart machines in our factories. I was in a presentation yesterday from Mazak. We're you know, helping on this OEE conversation that we brought up before, big focus of ours, and we want to partner with our machine tool vendors. You know, I think I would just say one of the concerns that we have, both as a provider and a user of smart machines, is sort of the model that we're talking about, that every machine is going to be connected to the cloud, and then the cloud is going to do something and come back into our factory. We're a little bit more focused on trying to figure out how those smart machines can collaborate inside of our factories. So how do we take a milling machine, a grinder, and our metrology or coordinated measurement machines and connect them into a more smart system in order to be able to get better outcomes from the parts that we're trying to make in our factories. And so you know, we didn't talk about it too much on the panel so far, but you know, I think smart machines are not so much a concept today as a reality, and that everybody needs to be having a strategy for that.
Yeah. Mike?
Right. I'll just add one point that sort of supplement what Carol and Paul said, was that an area that we've really explored on the smart side has been smart cameras with very advanced camera technology out in the field, processing at the camera level, sending information to an operator has been very valuable. We've utilized it, some very nice systems out in many different applications, and really has provided some very interesting analytics to the operation going forward there for. So we've used those in many different aspects there, and we tend to propagate it right across the organization. So one particular area, as we're obviously renewing different assets there, we're picking up new, smarter machinery in that, and we'll be utilizing them accordingly.
Go ahead.
Well, just real quickly, we're also collaborating with the Valley Mining Company in Brazil. We had one of the researchers there working with us this past year, and they're very deeply involved in the issue of automated mining for both operational reasons, because these things tend to be in unpleasant places to have people at, but also just to be able to run them 24 hours a day. And the idea of autonomous vehicles, some of which are basically the size of this room, being controlled by someone thousands of miles away. So it is happening now. Once again, obviously these are early experiments and early tests, but the idea of smart machines all around us, not just in our factories, is becoming part of the reality.
Excellent. Great discussion. And I really want to thank you all for listening, and please join me giving our panelists a big hand.